I find that math texts, explanations in books, and word problems are some of the most difficult reading materials students encounter in K-12 and maybe beyond. Although this statement is from 1994, it really does still apply today. Math, speak, and text is an integrated and often confusing blend of words, symbols, visuals, semantic and syntactical challenges, and lots of academic and math-specific vocabulary. Um, According to Zweers and others at the Understanding Language Stanford Center for Assessment and Learning and Equity at Stanford University, teachers can foster student sense making by amplifying rather than simplifying or watering down their use of a disciplinary language. For example, simplifying would be to continually refer to the numerator as the top number in a fraction, whereas amplifying would be to build on a student saying the top number by asking, well, what do we call that? And maybe refer to an anchor chart, or have the class chorally repeat the term numerator and put their hands above their heads while they're saying it so they get a visual of that idea. So there are different methods to increase awareness and understanding and use of academic language. And these are examples of amplifying versus simplifying. So we look here in research around English language learners. Let's take a moment to read this. I'll pause while you do so. So while we incorporate strategies to make mathematics and mathematical word problems more accessible to all students, the focus for students is still on the math. It's not on the technique or the language, and it's important to remember that access and work with applications, word problems, and larger tasks are important parts of math education for all kids. Here are 6 ideas from the Institute of Educational Sciences in a guide published online in 2012. It's called Improving Mathematical Problem Solving in Grades 4 to 8. The IES conducts a meta-analysis of research from which they draw conclusions and make recommendations, such as these 6 on the slide. So take a moment to look these over. I'll pause while you get a chance to look them over. And to let you know, all of these and many more techniques will be what we share throughout this presentation within the 6 categories I mentioned earlier, that I'm going to review quickly in a moment. Again, take a moment to read this. This is probably one of the last quotes we'll be reading today. So I want you to think about how this description of problem solving relates to how you see students solving math word problems and tasks. What level of thinking do the problems engage students in? What challenges do you see students having with word problems and tasks? I also want to notice the importance of students doing this type of work beginning in kindergarten. So it's not we wait until middle school or wait until they get strong foundation knowledge of mathematics and then they can start applying it. Students can start applying problems from kindergarten with the math they learn at that level with problems that fit that math. All right, so as mentioned, here again are the 6 categories under which I've arranged the techniques I'm sharing during this session today. With some of these techniques, I'll simply describe the technique. With some, I'll show examples to illustrate and clarify them. And with some, I'll actually have you do a little bit of the math, utilizing the technique in order to experience it a little bit better.